Hi everyone. When GitHub Copilot was released back in June of 2021, they only had support for Visual Studio Code. So if you are running any flavor of the JetBrains IDE like IntelliJ, Golang or WebStorm, you can use GitHub Copilot as they announced their support in 2021 for NeoVim and JetBrains 2. In this video, I will focus on GitHub Copilot for Java developers. I'll be using IntelliJ Community Edition, but this should work fine in the Ultimate Edition as well. So let's get started. GitHub Copilot provides suggestions for numerous languages and a wide variety of frameworks and works specially well for Python, JavaScript, TypeScript, Ruby, Go, C#, C++, and Java. I'll take you through some of the commonly played games and a simple Java program which we will implement first without GitHub Copilot and then later on we'll implement the same using GitHub Copilot. Okay, so now let's go one step ahead. Here we'll try to solve a challenge which says to design the system with the skeleton code where we have a scenario of an electric switch that turns a light bulb on or off, and we have to model this requirement with the skeleton code. So let's see it without GitHub Copilot. First, I'll go to IntelliJ. I'll create a new project for this and let it be a Maven project. From the archetype, I'll choose the quick start. Click on next. Give the name of the project as switch demo. Let's change the group ID to com.stackroot and keep other things as it is and finish it. So I'll click on this window. Okay, so the build is successful and our Maven project is ready. Okay, I have a source folder, inside that main, and there is a test folder. Inside this we have app and app test. Okay, now in this com.stackroot, let me replace this app with my own name. Let me refactor it and give it electric bulb. Okay, open this electric bulb, remove this comment. So in this bulb, I will create two methods. Okay, so I've created one electric bulb class which has two methods, two void methods on and off, and has print statements bulb is switched on and switched off respectively. Now I'll create another class named switch. Okay, so in this switch class, there is no class bulb, that's why it's giving us error. It's electric bulb. Now I'll create two methods. Where I'll set I should also have a constructor parameterized. Now let's create a main class. And create the object of switch class. Okay, so switch object dot device on. Now let us run this main class. So first time it has printed bulb is switched on, bulb is switched off, as we have called using the switch object device on and device off methods, which are present in the switch class. Okay, now let us create the JUnit 5 test for this. So how we'll do? We'll go to the electric bulb test class, remove these unnecessary comments, remove this default. So in this switch test, in the electric bulb test, now let us run this test. So it says method test device on should be public. Let's create it public and run again. So bulb is switched on. So this test case has passed. Similarly, I can just copy paste this same thing. Test device off. It has passed this test device off, whereas we have to change this device off also. Okay, so now let's run this electric bulb test, both the tests. And you can see both the test cases have passed, bulb is switched off and switched on. So how much time did we take to create this simple electric switch and bulb combination without GitHub Copilot? Quite a lot of time, right? So now let's see the beauty of GitHub Copilot. So we'll see the demo with GitHub Copilot now. So what I'll do, let us create a new project. Again, a Maven project. The name of this is electric switch demo. And again, change the group ID to com.stackroot. Finish and open in the same window. So let it build and pass. The build is successful and we are ready. So in the source we have main and test folders. Inside main Java com.stackroot and we have an app class. Similarly in test we have Java app test. Okay, so let's rename this app to bulb. We'll keep it as bulb this time. Open this bulb class. What I'll do, I'll remove everything. So I'll write a comment to create a bulb class. With on and off methods. Voila. So it has given me two methods with the string type on and off. I want to accept it, so I'll click on tab and accept it. Fine. Now let's create a simple new switch class. Let's keep it as electric switch here. I'll remove it. I'll type the comment. Create a switch class. So it is suggesting me that takes a bulb as dependency and has a method to turn it on and off. So I'll take constructor argument and has device on and off method. So I'll accept it. I'll click on tab, click on next. So I want to accept this. I click on tab and accept it. Now I'll click on creating a new main class. See, create a main class with main method and create objects for bulb and switch and call the methods. We want to do that? Yes. Okay, so it has created electric switch and bulbs, both objects, and it is printing out this one. Now let us run this. You can see the bulb is on, bulb is off has got printed, which is exactly what we did in our example without GitHub Copilot. Now if we have to do the same case for bulb test, what we'll do? So we'll go into this bulb test as it is already created. Let me remove this and write a comment. Create a JUnit 5. So it has suggested me two solutions, and if I run this, both the test cases are passed. Test bulb off and bulb on, and it is equals to bulb is on. If assert true, bulb off equals to bulb is off, which is as expected. So let's go one level up. Here we have challenge to try out a hangman game, which is a classic word game in which you must guess as many secret words as you can before time runs out. It seems a bit challenging to me, but let's try writing code for it first. Let's do it without GitHub Copilot first. So I'll create a new class called hangman. Hangman demo. Let me give one word to guess. So let us take this as welcome. guess what is empty. See, it is auto suggesting me, but I'll use my own. Int count is equal to 0. Okay. So we have written the code for Hangman demo. Now let us run this. Guess the letter, let's say Y, wrong guess. Guess the letter W, wrong guess. E, yes, it is there. L, it is there. C, it is there. M, it is there. O, it is there. W, wrong guess. W capital. Welcome, you won. So can you see how we have created this Hangman demo? I hope the code is pretty much clear. Now let us see, we have written almost 40 lines of code. Now let us see the same demo with GitHub Copilot. So now let's see the demo of creating a Hangman game using the GitHub Copilot. So what I'll do, I'll write a comment to create a Java program. Can you see it is auto suggesting me to implement Hangman game? The program should take a word as input from the user and then ask the user to guess the word. User should be allowed to guess the word 10 times. If the user guesses the word correctly within 10 guesses, the program should print you won. If the user within, the program should print you lost. So if I am okay with this comment, I can click on tab, which I am okay with. So I'm clicking on OK. Press enter. Press enter. You can, if you want to go with one-liner suggestion, press tab, enter, enter. So in one go, it has suggested me this solution. What I would like to show you here is, I would like to show you one of the cool feature which GitHub Copilot provides us with, that is ability to see full page suggestions instead of single one-liner suggestion. As we were seeing, we had to press tab to see one-line suggestions. So here on the right side, you can see GitHub Copilot, and here if I click on refresh, so you can see it will show me 10 full page suggestions instead of one single liner. Whichever solution you are okay with, you can select, you can click on accept the solution, and just the code will appear over here. So you can scroll. This is one type of solution. This is the another one. And similarly, you have so many other suggestions. Okay, as you can see, it has printed out the comment for me. I can use this feature to auto-complete it. Using the suggestions it will provide me. Okay, I think I'm okay with this solution, so I'll accept it. I don't want this. Okay, let's run this. Enter a word to guess. Let's say room. So enter a character. H, no. O, yes. M, yes. T, no. R, room. You won. So this is how hangman game is actually played. We have to give a word suggestion, and then based on that the other person has to guess that word. So can you look at the efficiency of GitHub Copilot, how it suggested me almost 10 suggestions, out of which I can just have a look at all the suggestions and accept the solution which is applicable to me. So now I'll quickly take you through another demo. So here we'll try to implement the tic-tac-toe, which is a two-player game in which the objective is to take turns and mark the correct spaces in the grid, which is usually a 3x3 grid as shown on the screen. The grids are available in larger sizes too. Now when you think of writing code to play this tic-tac-toe game, how easy it seems to you? Not very quite easy. You have to first think of the logic and then do several rounds of hit and trials to make it a success. Let's see the demo without GitHub, which I have already created to save time. So I have this tic-tac-toe game already implemented using the JFrame. So as you can see, near about 125 lines of code have been written, and you can imagine the time it took to implement this. So I'll just quickly run this. So this is how. Let's click on X. It will be the other players. Player 1 wins. Okay. So this is how it was done without GitHub Copilot. Now let us see how GitHub Copilot will help us to design exactly same or in a different fashion. So let's click new Java class. Let's remove this class and write a comment. Create a Java program to play okay. So I'll go to the GitHub Copilot and refresh to get the completions for this game. This is the third solution. Scroll down. There is also a solution with the extension of JFrame. There are several solutions. You can choose any one. Let's go with the first one. Okay, so it has completed this game for us, and near about 84 lines of code. Okay, so let's quickly run this game, tic-tac-toe game. Enter the row and column. Second row, third column. Second row, third column. Okay, I think I gave the wrong input. Let's run the program again. 1, 1. So it has formed this 1 for me. Enter the row and column. 2, 2. Okay. So 0, 1, 2 and 2. Okay. 1 and 2. Okay, 1 and 2. Now I want to play this game. 2, 1, 2 and 1. Okay. If I give 1 and 0, so player 1 won. As you can see, XXX has won. Player 1 has won. This is another way of playing this game, right? And this was done using GitHub Copilot. Did you notice the time it took to design this type of game? I think it was less than 10 seconds. You just have to write the comment and the game was done for you. So that's the beauty of AI pair programmer Copilot, whose main feature is its autocomplete function. Copilot is meant to work alongside developers to help them reduce tedious tasks and to speed up their work so they can get on to more important, interesting conceptual work. When you prompt it, it completes your thought, as we have seen in all our previous examples. So that's not it for the powerful Copilot. It has a lot more to it, which we will see in the later part of this series. Thank you.